Hello everyone, my name is Leihao Wei from Medical and Imaging Informatics Group at UCLA. Today I'm going to talk about the efficient and accurate spatial-temporal denoising network for low-dose CT scans. In this project, we utilize the spatial and temporal correlation in CT scans and introduced an efficient neural network structure to improve the efficiency to reconstruct high-resolution CT images from the low-resolution CT images. CT acquisitions are not always standardized. The image could be of lower resolution and noisy. Differences in image quality have an impact on downstream clinical tasks. The goal is to use a deep learning-based super-resolution approach to restore the high-resolution details from low-resolution images. The challenge is that since CT acquisitions are in 3D, using a super-resolution method without any optimization is computationally expensive. A deep neural network should be constructed with 3D kernels if we want to process 3D data. However, a CT scan can be viewed frame by frame, slice by slice. This observation gives us an opportunity to decompose 3D kernels into two components, a spatial kernel and a temporal kernel. We replace the 3D kernel with our spatial and the temporal kernel component in SRResNet, which is a baseline super resolution approach. It has been proven to be very successful in many applications. So this reduced the operation from 27 to 12. And then we name our network SRResNet. So here is a breakdown of the baseline SRResNet. It has a series of residue and residue blocks with convolution and activation layers. As we illustrated earlier, the 3D convolution blocks are replaced with spatial and temporal convolution blocks. We trained the network on a NVIDIA RTX 8000 GPU, and we also used Apex mixed precision training package to further improve the training speed. So here we show some example of super resolved images along with the input and the target. The baseline SRResNet is able to denoise the low dose input CD and improve the image quality as much as like the target scan. We combined the A-bit quantization with our spatial-temporal network. It resulted in minimal perceptual differences to the baseline SRResNet. As the region of interest shows, the differences between the baseline SRResNet result and the A-bit quantized ST-ResNet result at the nodule ROI region is visually imperceptible. So our ST-ResNet achieved better PSNR and SSIM compared to the baseline in the full precision floating point 32 inference. Quantization obviously have a negative impact on the image quality using PSNR and the SSIM metrics. However, compared to the baseline model, ST-ResNet with 8-bit quantization achieved even better perceptual quality by LPIPs. Especially when look at the acceleration factor, combining with the spatial temporal convolution, 8-bit quantization can achieve up to 7.11 acceleration in inference. And using ST-ResNet alone can also speed up by a factor of 1.67. And we also see a similar trend in training speed up. We also look at radiomic feature values and compare them to the values extracted from the baseline results. We selected 57 features such as first-order intensity, grid-level concurrent matrix, grid-level run length matrix, and grid-level size zone matrix. We found that 54% of feature values from the output of the quantized ST-ResNet were still consistent to the baseline distribution. So in conclusion, throughout our study, we demonstrated that the spatial-temporal ResNet, ST-ResNet, reduces the training and the inference time compared to the baseline SRResNet. We also showed that 8-bit quantization produced the result have minimum perceptual differences despite the information loss of computing a 12-bit CT scan using 8-bit quantized network weights. We also know that in our results, some radiomic features have statistically significant differences in distribution compared to the feature value calculated from the baseline SRResNet output. Further study is required to evaluate the impact of quantization to the downstream task, such as machine learning algorithm like long nodule detection,